Good morning. Welcome to the Science Group in conjunction with the Climate Change Initiative that Mark works on. We all welcome you here to the Wednesday morning lecture. I'm Bob Spiritus. I'm the organizer for these events. Our president is in the back greeting people, Bob Hopper, if you probably saw him coming in. We're glad you're here. This will be a nice day for science. Mark will say a little bit more about that after the presentation. Dr. Sherri Mason, also known as Sam, earned her bachelor's degree from the University of Texas at Austin. She completed her doctorate in chemistry at the University of Montana, where she was a NASA Earth Systems Science Scholar. As a professor of chemistry at SUNY Fredonia, her research group was among the first to study the prevalence and impact of plastic pollution within freshwater ecosystems. Sam has been featured in hundreds of mass media articles, including BBC, The Guardian, The New York Times, The Huffington Post, and NPR's All Things Considered. Her work formed the basis for the Microbeads-Free Water Act, which was signed into law by President Obama in 2015. Similar legislation has been approved or is being considered at various locations. Among her accolades, Dr. Mason has been awarded an EPA Environmental Champion Award in 2016, an Excellence in Environmental Research Award by the Earth Month Network in 2017, the Heinz Award in Public Policy in 2018, and a Great Lakes Leadership Award in 2021. She currently serves as the Director of Sustainability at Penn State University, Erie, the Barron College. We welcome her today. Please give her a nice Chautauqua welcome, Dr. Mason.
Oh, thank you so much for having me. Thank you all for being here. I appreciate the Bobs inviting me and Mark inviting me, and as part of everything that you guys have going on, but the Wash to Shore exhibit, so we'll be making reference to that, and the Climate Change Initiative, I'll be making reference to that as we go through the talk as well. So I always kind of go into a public presentation like this, kind of assuming that while we all use plastic, right, every day, many of us are probably wearing some plastic sunglasses. I have my pair, right? We show here chairs and combs and lighters and plastic bags and frisbees and bottles of water, right? So we use plastic every day, but I am a chemist, so this is always my question, exactly what is plastic? Because I don't know that many people kind of fully comprehend while you use it what it actually is. And this is how I understand the world, so forgive me, but this is how I'm going to start this presentation. It is a science presentation, so you don't have to forgive me too much, right? You did come into it expecting a little bit of science, right? So plastic as this material that we use in ever-increasing amounts every day is ultimately composed of a polymer. So a polymer, I like to think of it like a train, right? A train is this really long transportation device, but it's composed of repeating units, right, that are linked together. In the same way, a polymer is a really long-chained molecule, like thousands, tens of thousands of units long. But those units are identical and they repeat as you go through the chain. So here I'm showing ethylene monomers that are being linked together through the polymerization process to form polyethylene. PE for short, and this is the most common plastic that's manufactured. You as a consumer experience it as high-density polyethylene and low-density polyethylene. These polymers, so high-density polyethylene, low-density polyethylene, these are numbers 2 and 4 if you've ever looked at a bottom of a recycling, right, of a piece of plastic. You'll see these plastic resin identification codes. This is important for us to we'll come back to this later, so, make a mental kind of pinpoint now. But these resin identification codes are telling you the polymer that is in that plastic item. Okay, that's what they're identifying, right? So number ones are things that are made out of polyethylene terephthalate, for example, okay? The resin identification codes starting in the 1980s were developed by industry with the anticipation, this was the first backlash against plastics, right? This is right after the crying Indian. Which is now pulled off of YouTube, so I can't show it to you guys, but you all know the crying Indian, right? And Keep America Beautiful starts. So this was the kind of the first backlash against plastics, and this was industry's kind of solution to the problem. Oh, we'll create these resin identification codes to make it easier to identify the types of plastics that are out there, and in theory, increase recycling. Which is why, I mean, in their mind, they use the recycling symbol. Now, it depends upon how far down a conspiracy rabbit hole you want to go, but many of us have issues with the fact that they use that recycling symbol. We feel like that was intentional to confuse the consumer, because if you look at something and you see that symbol at the bottom, you assume that it can, in fact, be recycled, right? Yes, not correct, right? So it's part of the resin identification code. It does not mean you can actually recycle that piece of plastic. So for example, number 3, polyvinyl chloride, come up in the news recently. Does anybody remember why? Train wreck. Just down at the Ohio-Pennsylvania border. There was a train wreck that was shipping vinyl chloride to be turned into polyvinyl chloride, right? This is a very, very toxic substance. The residents of that town are going to be dealing with the consequences of this for years, if not decades. That's just the reality. And this plastic cannot be recycled. Polystyrene, number 6. Which you probably most commonly think of as styrofoam, though that is a trademarked name, so little R there. But polystyrene is another one of these plastics that really, in any kind of real way, cannot be recycled. Okay, so it's something for you to keep in mind, that when you see these codes, that doesn't necessarily mean, is that person okay? Sorry, now I just made them very self-conscious, but when you see somebody fall, you just want to make sure they're okay. So, okay, they seem to be okay. We have several doctors in the room, okay. I'm a doctor, but a useless one, is what I like to say. Okay, glad they're okay. So we'll come back to this idea, but I wanted you to understand what these codes represent. So they're identifying the polymer that is within that material. How did this material come into being? How did it, if it's not obvious, I probably should have stated it when I was showing the ethylene, right? Where does ultimately plastic come from? Where are the starting materials coming from? Fossil fuels, right? So this is not a natural material. It's completely man-made. I mean, by definition, plastics are man-made substances. How did this material come into being? Well, it really started with this object, the billiard ball, right? Which traditionally was made out of ivory, and hence billiards, right? The game was, it was a game of the elite, right? Because they were the only ones who could afford it, right? Probably have some business owners in here. If you're like hitting a wall on like your like limit of rich people that can buy your product, what do? You like, well, how can I market this to the masses? How can I make a billiard ball out of something other than ivory? And this is at the same time that we were hitting limits on many natural products. Hair combs were made out of tortoise shells, right? And this is where you get the gift of the Magi, that story, right, where they're poor and she sells her hair to get a guitar, I don't remember, and he sells his object to buy her a hair comb, right? And I remember reading that story in high school going, how expensive were hair combs? Like, it was completely irrational to me. I wish my English teacher had explained that hair combs were made out of tortoise shells, and they were really, in fact, expensive, right? I mean, I grew up in the 80s. A hair comb at the local CVS was like, 7 cents or something, right? And that's because of the advent of plastic, right? So this material really was born from this bump up. I mean, it's kind of ironic, right? It was actually born for very altruistic reasons. We were bumping up against these walls with natural products. If we can make something by man, right, we can not have this reliance on these natural products as much, right? And so it was actually kind of to save the environment, right, to save the natural world, that we created the first plastics. Celluloid was the first plastic. Bakelite was probably the most widely kind of first big kind of plastic, although celluloid was used to make like the first films, right, so the celluloid industry. Wasn't actually, it was developed to replace billiard balls, never actually replaced billiard balls because it's slightly, explosive. You crack those billiard balls together, a little bit of an issue. So instead, we turned it into film and put it in front of really hot light bulbs, because we're smart. Standing in the house of the Lord, just a little reminder at all points in this conversation that we should be a little bit more humility in us as people. We never know as much as we think we do. So that was the first plastics, but it wasn't really until World War II that this material started to be produced in a mass scale, right? As part of the war movement, we needed metals for bombs and planes and bullets, and not for lunch boxes, right? So there was a huge need for this material. We needed parachutes, right? There was a huge need for this material, and so you see the mass infrastructure be put into place as part of the war movement. And when the war ended, industry said, that's okay, we'll just leave our factories. No, of course not, right? They're like, okay, if the military is no longer gonna be our top purchaser, well, who would be? Well, that's you guys, right? Us, as consumers, right? And so started the advertising campaign, right? And this is this iconic ad. If you've ever taken a marketing class, this ad is in every class across the United States, right? Really kind of this demarcation between a society of saving and conservation and reuse to a society that is throwaway, right? Look at our subtitle here, disposable items cut down on household chores. See a lot of women in the audience. How many, well, I won't be gendered here. How many of us love doing dishes? You can leave now. You can come to my house and do my dishes, right? I also have weird things, like I love cleaning bathrooms. I know, right? Yeah, no, everybody's gonna hire me now, I shouldn't say that. I find it very, soothing, I don't know. There's some psychologist out there who's gonna, process that information and tell me something later. But, really kind of marketed this as, forget washing the dishes, you can just throw them out. Get mom out of the kitchen, right? And this is where I said women, because, this was a period of time, right? The 1950s, where traditionally it was the woman who was at home, who was doing the dishes and washing the clothes and those things, right? So it was really marketed from that standpoint. It was really marketed as, this is gonna make our lives easier, and it has, and more convenient, and it has. That's all true, right? And what has happened, therefore, over time as part of the emergence of this material, its acceptance into our consumer culture, and its replacement of other materials like glass for Coke bottles, is this exponential increase in plastics production, right? Over our lifetimes, everybody in this room, this has happened. You've seen it, right? And we all go, oh yeah, I have witnessed this happen, right? I remember growing up and bottled water was not on every person's lip and in every person's hand. I grew up in Texas, by the way. How did I survive without bottled water? We used to run up to random houses and turn on the spigots, right? Yeah, that's how you got water. So to the point where in 2019, and later I'll show you more data from 2019, we were producing 465 million metric tons of this material. Over the course of these 70 years that this has really been in production, we have amassed 10 billion metric tons of this material. That's just a huge number. And I should mention, you've probably noticed this, like plastic is really lightweight, right? So we're talking about 10 billion metric tons of this incredibly lightweight material. It's really kind of hard to put your mind around that. So my colleague Roland Geyer tried to, and he equated it to 1 million Eiffel Towers, 100 million blue whales. I don't know that he was terribly successful. I mean, I can't even imagine what a million Eiffel Towers looks like, but it gives you the idea of just how vast a quantity, right, we have created. So where is all of this, right? What's happening with all this? I used to show kind of over that 50 years what happens to it. I decided instead to do a snapshot of just in 2019. So just 2019, virgin, material, okay, most of which is fossil fuel based, right, is 430 million metric tons, 2 of which is the bio-based. So 99% of it is coming from fossil fuels. That's the virgin feedstock, fresh out of the ground, okay? But that's not everything that we use because, of course, there is some that gets added to that, okay, from the recycling. So with 465 million metric tons of plastics that were actually used in that 1 year. What happens to it? Various applications, right? Some of which are durable, right? I drove here in a car that has a frame that's made out, or an outside shell that's made out of plastic, right? The dashboard is made out of plastic, right? Frequently I'm talking in classrooms and I say, you're sitting on chairs that are made out of plastic. That doesn't work here. Your refrigerators have shells that are made out of plastic, right? So there are some durable goods, right? They make up about 2/3 of the market, but half of those get thrown out every year. And then that other third is the non-durable, the completely disposable goods. Okay, so we end up throwing out 353 million metric tons of waste just in this 1 year. That's the waste that's created. What happens to it? Half of it ends up in a landfill, quote unquote, correctly disposed of. 9% of it gets recycled. So that's being that difference between the virgin and the polymer production is that 9% that gets recycled. About 10% ends up being incinerated. Yeah, something like that. For 67 million metric tons, 22% is actually released into the environment. 22% is released into the environment. 9% is recycled. In that 1 year, more than twice what we recycle is released into the environment. You really have to process that, okay? So when we're talking about solutions, you need to be thinking about this chart, which, by the way, took me way too many years to put together, or too many hours to put that one slide together. I was telling my husband, I was like, I spent 4 hours on one slide today. He's like, oh, God, what is wrong with you? And I was like, I don't know. So when we say released into the environment, I know, and washed ashore is right, trying to kind of raise awareness, but I think most people are aware of the fact that, this is, much of this is ending up in our world's oceans. And in fact, from a scientific standpoint, this was kind of where the science of plastic pollution research started. It started in the world's oceans. There was a colleague of mine in the early 1970s. Well, he wasn't of mine because it was like the time I was born, but he was a student from Fredonia, and then he went out to Woods Hole Oceanographic Institute where he did this work in the early 1970s, identifying the first plastic pollution in the North Atlantic Ocean. Up here. But it's Captain Moore's work in the Great Pacific Garbage Patch, or the North Pacific Ocean, that's probably gotten the most press. It is the biggest collection of man-made debris. But all 5 of the oceanic gyres have mass collections of marine debris, 80% of which is plastic. So I know that this started in the world's oceans, and washed ashore is really kind of trying to represent that. But the reality is that what we're seeing in the world's oceans is making its way into oceans through freshwater systems. And that's part of the story that I don't think, it's the newer part of the story, right? It's the part of the story that I come in on. And my first paper came out, and the first papers on freshwater plastic pollution all came out in 2013, so 10 years, yay. But it's not one that I think is discussed enough. And I think it's really important that we talk about it, because not that many people necessarily feel connected to the oceans, right? I always say, if you live in Iowa, do you really care what's happening in the Pacific Ocean? Probably not, and that's not like, people being callous. It's just we care about what's in our backyard. But if I tell you that Chautauqua Lake has mass collections of plastic in it, I don't know that actually, I'm just gonna preface that. But if I tell you that, right, you feel connected to that. I'm sure it does, I just haven't done studies on it. And so this is the part of the story I think it's important, right? It's people are connected to fresh water. We need fresh water for life, right? This is what we drink. It's what we bathe in. It's what we cook with, right? So this is that little known part of the story that I think is incredibly important. Anybody want to venture a guess where this picture was taken? I think when I do this to students, they're always like, Bangladesh, or like India, all those Asian countries. It is Erie, Pennsylvania. This is Mill Creek in Erie, Pennsylvania. So it's making its way to Lake Erie. This is one of the litter booms that we have. We have 2 litter booms currently installed in the city of Erie. Where I currently live, and this was where I spent the last 2 years-ish of my life doing research, counting and quantifying all of that plastic. I am tired, yes, thank you. My back hurts. I kept going to the chiropractor and the masseuse and being like, I don't understand what I'm doing, that my back is hurting so bad. And then the next time I was out I was pulling in this stuff with this pool skimmer, and I was like, oh yeah, really heavy plastic, wet plastic probably has something to do with it, yeah. So my work did start right in the Great Lakes, aboard beautiful U.S. brig Niagara, whose home port is Erie, Pennsylvania, right? But this is, I've always lived, for 20-ish years, I've lived, along the shores of Lake Erie. And so I feel a serious connection to the Great Lakes. I know here we're in a different watershed, but we're not that far, only a few miles from Lake Erie. And I think what's really important here, this is the largest freshwater ecosystem in the planet, right? I think it's so easy to forget that because it's our backyard, right? But the world over is dying for fresh water, literally. And we have so much of it, and it's our backyard, right? And so I think it's really important for us to be cognizant of that on like a daily basis, how important and how lucky we are to have Lake Chautauqua, to have the Great Lakes in our backyards, and be able to make use of them and appreciate them and experience them. So I have sailed and sampled and swam all 5 of the Great Lakes. Starting up in Lake Superior, what we find is an average, right, largest of the Great Lakes, the most pristine, the least densely populated. We already are finding 30,000 pieces of plastic per square kilometer of the lake's surface. I always forget to preface this slide with that. These are just lake surface numbers. Half of plastics, when they're manufactured, sink. So already you should be doubling this because there would be more in the sediment. But in addition, plastics, when they're out in the environment, will build up what are called biofilms. Little microorganisms will live on the surface of the plastics, kind of like the way we live on the surface of this planet, right? So they'll live on the surface of these plastics, causing their density to increase, and so they will sink. So you actually find more in the sediment than you do on the lake surface. So at a minimum, double these numbers, but there's even more than that probably, or we know for sure. But I do water measurements. I've done a few sediment measurements, but I tend to focus on the water. I like it better. So in Lake Superior, we're already seeing an average of 30,000. When we sail into Lake Huron, that count goes up to 46,000. Why? And more people, right? So it's flowing, right? You have everything that's flowing from Lake Superior into Lake Huron, and then you have people that live around Lake Huron, right? All those Michiganders, should blame them. And like Sarnia. When we go into Lake Michigan, our current average is lower. I think that is really only because while I'm showing here an average of studies from many different labs, not just my own, Lake Michigan, the only sampling that's been done in Lake Michigan is actually from my lab. And we planned our cruise because in the southern area of Lake Michigan, there usually is a seasonal gyre, but that year was an off year. So we've done a lot of our sampling in the south to look at those high counts, but it was just an off year, and so it wasn't where we expected it to be. So I think our numbers are artificially low. I think what's important here when you're looking at these numbers is to recognize that geologically speaking, Lake Huron and Lake Michigan are actually one lake, right? Because they're at the same elevation, and they just have the peninsula, which is the great state of Michigan, that juts into this one giant lake. So the reality is that the number in Lake Michigan and Lake Erie, or Lake Huron and Lake Michigan is probably somewhere in between those two, but higher than the 30,000. It's probably somewhere in like the high 30s is what you would kind of expect if you average across those two lakes. Then that water, right, from Lake Huron goes down into Lake Erie, right? Our lake, the shallowest and the most densely populated of the 5 Great Lakes. What do you think happens to the number? It goes up, and it goes up dramatically. And then that water flows across, Niagara Falls into Lake Ontario, and the count goes up to 250,000 pieces of plastic per square kilometer of the lake surface. And that's what's flowing out into the North Atlantic Ocean, right? I know that these numbers are always a little awkward, so if you account for the surface areas of the lake, each of our individual Great Lakes have somewhere between 1 and 5 billion pieces of plastic on their lake surface. And again, at least as much, if not more than that, in the sediment. So it's a lot of plastic. 97% of these plastics are what we classify as microplastics. Okay? So if you go out to Lake Erie and you look in the water and you go, well, I don't see any plastic, that's because it's really small. Really, really small pieces of plastic, 97%, right? And so there's a lot of breakage of the plastic happening on land before it makes its way even out to the Great Lakes, which is why I've started looking in rivers, trying to get a better idea of where the plastics are coming from, aside from the obvious consumer products, but a better kind of accounting. And I can tell you the number one thing is bottles. It just preempts the end of my talk. But it's bottles. So if you want to do something, stop buying bottled beverages, period. Don't. It's the number one thing that we find. It doesn't matter where we look, we end up finding bottles. So some of these microplastics are what are classified as primary microplastics. So that means that they were manufactured to be in this category to begin with. They were manufactured to be micro-sized. Microbeads is the most kind of well-known example of this, right? But when plastics are born, when they come out of a refinery, right? We said that they start with fossil fuels, right? Fossil fuels go to a refinery, crude oil goes to a refinery where it's then separated into its different components, part of which is gasoline that's used for cars, part of which is diesel that's used for other transportation, right? And then part of it is turned into plastics, right? And it's shipped from a refinery to a manufacturing facility as these pre-production plastic pellets, commonly referred to by anybody who's not in the industry as nurdles. And I thought it was an industry term, and then I met industry people, and they're like, no, we've never heard of a nurdle before. They call them pre-production plastic pellets. And if you don't know, 10% of all plastics touch Erie, Pennsylvania. So if you want to know how close you are to the heart of the beast, well, I live there. It's a really big plastics industry. It's one of our top employers in Erie, Pennsylvania, is plastics. So I don't think I have them in my actual PowerPoint, but I can show you images of pellets underneath trains that have been shipped from the new facility in Beaver County, Pennsylvania, up to Erie, Pennsylvania, to be transported to the various manufacturing that we have in Erie. So we find these by the millions, in the sediment and in the rivers of Erie, Pennsylvania, because they're really small and they're easily lost. And I show this in class because I was mentioning to Janice before the talk that, our number one, I work at Penn State Erie, Penn State Behrend, as it's commonly referred to. Our number one major is plastics engineering technology. So we're actually, not me. It's a little bit of a tension happening right now at my institution. But, our institution is training the next plastics makers, right? So I frequently in my general education classes have students from plastics engineering technology in my classroom. And of course, we have at least one lecture on plastic pollution a semester, of course, like duh. And I know that many of the students are always like that day, they always get a little tense, like there's gonna be this like fighting happening. But generally speaking, there's not. They agree with everything I'm saying except for the solutions part, which we'll get to. But I'll show images of these, pellets that we find under trains. And, my last class, this kid Ian raised his hand, and he's like, that pile there is probably not even like a half a cent worth of plastic. But I find piles where there's literally millions of pellets. And he's like, that's pennies to them. And I'm like, yeah, exactly. It's pennies to them. It means nothing to their bottom line. But to a fish or a frog or a turtle or a human that eats that fish, it's a lot. And that's not being accounted for. They don't have to pay for that. We do. We're paying for that every day. Primary microplastics. Most of what we find are what we classify as secondary microplastics. So these are things that broke off of something that was bigger. I don't like to say break down because that sounds like it's a biodegradation, right? Like it's a decomposition. No, plastics don't decompose like that. They're not biodegradable. They go through a photooxidative degradation. So sunlight makes them brittle, and then cars drive over them, or people step on them and they break. And they get ever smaller. But in terms of the chemistry, in terms of the polymers, very little has happened. They're not degrading, which is why you hear like that plastic bag is going to, has a lifetime of decades. Or your shower curtain has a lifetime, a PVC shower curtain has a lifetime of like centuries. Because they don't degrade in any kind of appreciable way, any real way. They just break into these ever smaller pieces that are secondary microplastics. I mentioned, so 97% of what we find, in the lakes are microplastics. I gave you some idea of the counts. I think I put this in here just because I wanted to highlight that when we look upstream from the lakes into the rivers, the counts are even higher. Right, so this is an image coming from all the studies just in my lab, basically, along with the rivers, and you just see that it's exponentially, this is a logarithmic scale, so exponentially more higher concentrations in the rivers, because you're closer to the people, and there's less water for it to be diluted. So as we move from the water back to land, you see the counts going higher. And I probably should have entitled this talk, From Land to Sea Back to People, because that's in fact how the cycle goes, right? I think later I have the question, why should we care? I think all of you are here because you already do care, but this is right ultimately why we care, because this comes back to bite us, right, in our own asses. Excuse me. I'm trying really hard to be good. Anybody who knows me knows that I have quite the, 10 minutes, oh yikes, okay. So we'll go through this faster, but this stuff does end up in the things that we eat. So salt, we've looked at sea salt, we've looked at beer for obvious reasons. We looked at tap water, and we have looked at bottled water. Yeah, so if there's any doubt, first of all, some important things to take from this slide. One, beer is better for you than anything. You're welcome. More seriously, bottled water, right? Anything that's packaged in plastic is going to have a lot of plastic in it. And in fact, bottled water is the #1 way that we currently are aware of that plastics are making their way into us as humans. With just breathing being another major pathway for these. So, because our carpets are synthetic, and then when we walk on them, fibers go into the air and we breathe them in, and they're just in the air too from all of the, synthetic fabrics that we make nowadays. So it's just always in the air. So here is that question, why do we care? If I haven't made the point, here's some headlines, right? It's been found in poop. Probably the most depressing one is a study of my colleague where they found it on both the maternal and the fetal side of the placental boundary. So there's no doubt that it's making its way across almost that most sacred of boundaries and ending up in our children before they're even born. And to make that more clear, right, baby poo has 10 times more plastic in it than adult poo. And that is in part because babies crawl on carpets and they play with plastic toys and they chew on everything, right? It's been found in our blood. It's been found in our lungs, right? So at the start, right, I showed you this image, right, that plastics are ultimately made of polymers, and that is one of the issues. When we talk about the health consequences of plastics, one of them is the polymers themselves. And the polymers, this is the most recent kind of data that's coming out, is showing that it is connected to neurological disorders like Alzheimer's and Parkinson's. It's a very insulatory material, right? We wrap wires in plastic. So if it gets between the synapses of your neurons, right, it prevents transmission of neurological signals. I predicted this 8 years ago. But science is starting to catch up with that. So this is the front end of the science on plastics and the impact on human health. I mean, these came out just last year, 2022. So this is where we're getting. What we do know a lot more about is the other side of the plastics industry, which is the fact that plastic doesn't just have the polymer. I mean, if you looked at this slide and thought, well, she's got a lot of empty space, well, don't worry, I'm gonna fill it up, right? We add plasticizers and UV stabilizers and colorants and flame retardants, right? If you've heard of PFAS, right? PFAS are flame retardants, plastics are one of the uses of those. There are 10,000 different chemicals that are used in the manufacture of plastic. 3,000 have been shown to have human health impacts. So you're thinking, oh, well, the other 7,000 are safe? No, we just don't have data. We just don't know. 3,000 we know about. The other we just don't know. We don't have the data because the way our regulatory system is in the United States is it's innocent until proven guilty, which sounds great when you're talking about people, but I have a bigger issue when you're talking about chemicals. Because the onus for us to prove that a chemical is causing harm is on us, not the industry who's making the billions of dollars off of it. It's on us to prove that it's guilty, and that's a really hard thing to do. Really hard thing to do. Where was I going with that? I don't know. Okay, so these chemicals we do know are endocrine disruptors. That means that they mimic natural hormones, which are basically the chemical messengers of the body. So we're basically, that game of telephone. Did y'all ever play that in camp, right? We're doing that with our bodies, right? Where the signal is getting disrupted by these synthetic chemicals. And what we know for a fact, connected to the rise in synthetic chemicals in the environment, specifically with plastics acting as a mechanism to move these into us, sperm counts are going down. Intergenerational penal size is getting smaller. Yeah, you heard that right. I'll let you process that for a little while. Cancers, specifically ovarian cancer and breast cancer in women, prostate cancer in men, autism and ADHD, it's not vaccines. It's not vaccines, okay? I know we have a presidential candidate out there. I know, he's insane. We all know he's insane. Okay, but just to be very clear, okay, it's not vaccines. It's the rise in synthetic chemicals in our environment, and especially those that are connected to plastics, and obesity rates. are also, and it's because this stuff is actually modifying us at a genetic level. If you do not believe me or you want to know more information, Our Stolen Future, written by Theo Colburn, she was the grandmother of the endocrine disrupting chemical. Like she launched the awareness of what these chemicals are. She passed away just a few years ago. Amazing, amazing woman. Did this all after having 3 kids and being a pharmacist. In her 50s, she was like, I think I'm gonna go and get my PhD and start a whole new area of study. And I'm just like, I wanna retire. And she's like starting a whole new area. And then this book came out just 2 years ago, I think it was 21, Countdown by Dr. Shauna Swan. How our modern world is threatening sperm counts, altering male and female reproductive development, and imperiling the future of the human race. It's a light read. Chapter 7 is the whole chapter's on plastics. The whole chapter's on plastics. So I'm probably already out of time, but I'm gonna. So when we're talking about solutions are really important. And if you want to know, so I'm gonna go through this really quickly because I'm out of time and I love Q&A. I really, really do. I just also like to talk. I'm a professor. That's what we're known for. But tonight we have a whole documentary, and I know you're gonna talk a little bit about it too, but 7 o'clock, 5 o'clock? 5 o'clock tonight, Janice Overbeck, who is the creator of the movie. I just am one of the talking heads in it, but she created the movie. It was her idea. It was her brainchild. So she's here. We're going to have this movie and talks about the 10 kind of main solutions to this issue. So please come to that tonight. But this is my pitch for the most important solution. And y'all are trying to figure out why there's an overflowing kitchen sink on the screen, right? Like, why is that on the screen? Because if this is what you come home to, what's the first thing you're gonna do? Turn off the tap. You're not gonna start cleaning up? No, because it's still flowing, right? And I have to talk about this because always the question is, well, how do we get this out of our water? How do I keep this out of my body? Well, I'm sorry, but we need to be thinking upstream from that. We need to be thinking about our kids and not ourselves. We need to turn off the tap. This is the number one thing that we need to do, is decrease our usage of this material. We had society before. We can have a society still and be using less plastic. So I love this image. I know I don't have time to talk about it because my moderator is being very good and gentle about telling me I'm out of time. It shows the different ways that plastics is used, right? And when the industry touts its benefit, it tends to focus on things like healthcare and automotive, right? But that's a small portion of how plastics is used. The number one, the biggest part of the plastics industry is packaging. It's the bags, it's the bottles, it's the straws, it's the takeout containers, it's all of that. And I think we have another way that we can get our crackers home than packaged in plastic. I think we can come up with something. So really just decreasing our usage and being aware that there are a lot of options out there. And with that, I thank you, and I
Just be careful of this.
yeah.
Thank you, Dr. Mason. As we're getting ready for the Q&A session, please come up to this microphone so that we can get your questions. We're also going to try to get anybody out there in Zoom land can put something in the chat box, and Dr. Cameron will try to announce those questions. I want to make sure that we thank Dr. Mason and mention the fact that next week we will have Nicholas Moy talking about monitoring air and water pollution in national parks. So please come back, same time, same station, next week here. And Mark Wensler, the head of our climate change initiative, has a quick announcement, and then we'll go to the Q&As.
Thanks, Bob, and thanks, Sam. That was wonderful. So I'm Mark Wensler. I'm the Peter Nosler Director of the Chautauqua Climate Change Initiative, and the actual Peter Nosler is here. Thank you, Peter. I also want Janice Overbeck, if you would stand up. Sam mentioned we have a wonderful film at the cinema tonight at 5, Plastic Earth. It's really a must-see, followed by a conversation with Janice and Sam. The film will also be shown on Thursday at 2. And finally, I'm sorry?
What location?
Chautauqua Cinema. Finally, on the solutions piece, every Wednesday and Sunday on Bester Plaza, so that today, noon to 1:30, we have a table set up, and we have a display of alternatives to single-use plastic products. So Sam's last slide with, you can actually come and see those and get a sense of what's out there. So please join us. And then Bester Plaza, every Wednesday and Sunday, noon to 1:30. And you can get a free refillable, sustainable water bottle if you sign a plastic reduction pledge.
Woo,
With that,
nice.
Q&A.
I love it.
Please.
All right.
Okay, just a 5-second quick, 2001, when I was in El Salvador and I had to step through a foot deep plastic bottles. I haven't used a water bottle since 2001.
Nice.
Is there any work on breakdown of plastic bottles, like bacterial or some other breakdown of plastic bottles that is being done?
Probably more importantly, they're looking at these like bio-based or biodegradable plastics, though they still have a lot of the synthetic chemicals that we were concerned about in them. There is, and every time a new bacteria is discovered, my Facebook feed fills with them. The problem is that microbes tend to be very specific. They're very picky on what they eat, and so they'll be like, I like polystyrene, but nothing else, or I like PET, but nothing else. And if we talk about the recycling industry, it's sorting plastics into the myriad of different plastics is really difficult. So if you're talking about a microbe that is only going to feed on one type of plastic, well, you have to sort that one type away from everything else and get it in a big enough quantity. And again, we have issues already with leakage into the environment. So yes, that is happening. I don't see it as the best solution. Is it a solution? I think there's a myriad of solutions out there. So I think moving to more, I mentioned that plastics are made of polymers. Polymers, there are naturally occurring polymers, right? Our hair, our skin, our DNA, the tree that's outside, right? That's all, there it is. They're everywhere. Those are all naturally occurring polymers. So if we can use naturally occurring polymers but reduce our usage of synthetic chemicals within those, I think that's a better solution than looking for microbes that can eat the waste that we already have. Yeah.
So I'm wondering.
Don't touch the mic. Just talk into it, it'll hear you.
Okay. I was wondering about the trade-offs and different environmental concerns. So I write to manufacturers all the time and ask them, why aren't you using glass instead of plastic? And one actually got back to me recently and was talking about that glass is actually worse for the environment because of the energy used in creating the glass. And so that threw me in a, whoa, my mind blown.
Yeah.
So what is the trade-off, and how do we determine that, and what do we do about all of that?
Yeah, so the chancellor of my university, which is basically the president, Penn State just has a weird way of naming things, was recently in the newspaper saying the same thing, that if other people, and I knew who he was talking about, me, if other people knew what he knew, they would be drinking more out of plastic instead of glass. It was great. It was the best day of my life. I was very appreciative that a local resident emailed him and Amy Bridger, another employee, and asked where they were basing that. And she sent them where they were basing that, these life cycle analyses, and she was very kind to share those with me. So I got to see behind the curtains. I love people, some people. So I went through their life cycle analyses that they were basing this on in painstaking detail. So I've learned a lot about life cycle analyses. So that's where it's coming from, is these life cycle analyses. Now, what's important with life cycle analyses, because I looked into like the theory of them, is that the number one thing they tell you, if you were going to go take a class in how to do a life cycle analysis, is that it is heavily dependent upon your location. Because they include things like transportation of the materials to your location and things like that. So it's highly dependent on your location. Not there, I looked at a review of life cycle analyses, which is a fairly new field. They've found 25. One of those was in the United States. One. So and the ones that they sent that said glass wasn't as sustainable as plastic were from the UK and Italy. So not the United States. Okay, I think that's really important because it's going to be a different math if you're talking about a different location. It also depends on whether you're talking about manufacturing glass virgin from sand, and that's where the most energy-intensive part of the process is. Glass, however, is infinitely recycled. You can take a glass bottle and turn it into a glass bottle and turn it into a glass forever. And if you're talking about recycled glass, the energy is far less than even recycled plastic. So if you're going to compare a virgin glass bottle to a virgin plastic bottle or a recycled plastic bottle, then yeah, glass is going to look worse, right? But if we had the infrastructure in place, right, if, as part of Coke moving from glass to plastic, a lot of glass manufacturing went away. And does it need to come back? Yes, it does. It just does. But we do have some, where I am in Erie, there's a glass recycler. We collect glass in Erie, but it's shipped to Cap Glass, which is outside of Pittsburgh. And so it'd be really interesting if my chancellor is going to say that, to do a life cycle analysis for Erie. Yeah. All the other stuff, yeah. So, yeah, and so the next point that Janice is making is that no life cycle analysis includes any type of human health or ecological impact. They're completely ignored. It's just CO2 emissions. That's it.
And it's rapidly changing with the new hydrogen ferries and the new electric boats and trucks.
Yeah. Yeah, so that's why I said where you're at is highly dependent, because it's how it's being transported and what is the energy source for that transportation. In Erie, Pennsylvania, we're making the next iteration of electric locomotives. Steel is going electric. Everything is becoming electrified. And where is that electricity coming from, right? And the whole point of going to electrified is to get more of the electricity coming from solar and wind and water, right? And less about coal. So these LCAs are rapidly changing. So the answer to your question is it's complicated. That's the short answer. I probably should have started with that. But I am not going to throw out, right, glass over, I'm still going to choose glass over plastic, because I want that infrastructure to be built out and not the infrastructure for plastic. And mind you, the infrastructure for plastic is coming to your neighborhood, right? There is a huge build out of plastics industry happening in Pennsylvania and Ohio. I know it because I live there. It's happening, and it's because of hydrofracking, and I know you guys are smart in New York, because I used to live here, and y'all have banned it, at least until you get a Republican governor, which hopefully will never happen. But in Pennsylvania and Ohio, we have a lot of hydrofracking. I know that they tout hydrofracking as energy. No, it's going to plastics. And there's a new plastics facility in Beaver County that's making polyethylene. There's 2 more planned for just down the Ohio River in Ohio. There's an Encina plant, which is looking to take waste plastic and turn it into energy or fuel. These advanced recycling, which is really, really dirty. Really, really dirty. And the citizens in this town are fighting it, but it's a hard battle. As they put more and more of these multi-billion-dollar companies in, they're going to want to use them, right? They're not going to walk away from them, right? So you have to support kind of where you want the world to be, right? And the more you purchasing plastic, you're helping to support this plastics industry, and this is growing here. We are turning, this area of the world is becoming the next Cancer Alley. It's becoming the next Louisiana. And we have the choice on whether or not we want to support that or fight it. And we fight it every day with the dollars that we spend, and we fight it with the people that we elect to represent us. Yeah, sorry.
Okay. Thank you for the segue. I live in the Pittsburgh suburbs, about 30 miles away from the Shell polymer plant. We don't want it.
Yeah.
And I would encourage everybody to Google Eyes on Shell. We formed a grassroots group to
Yeah.
watch them.
Yep.
The nurdles, we
Yep.
know what nurdles are. They've already escaped into the Ohio River. We watched their flaring.
Yep.
In fact, 2 of our environmental groups are taking them to federal court for breaking their permit.
Yeah.
And you can see the flaring as far away as 30 miles.
Yeah.
Okay. Now, the other thing, I'm sorry for the commercial here, but many of us are telling ourselves, do not live in Beaver County. It's not a safe place to live because of the air pollution. We already have a resident air pollution where Allegheny County is one of the dirtiest air counties in the country.
Yeah.
Okay, so it's adding to it. A little bit unknown fact, that plant is creating over 2 million tons of carbon dioxide in a year. I hear that's a greenhouse gas. And they're creating 1 million tons of polyethylene pellets. And the ethane required to make that comes from fracking.
Yeah.
We have fracking all over the place.
All
in the
over.
area.
It's bad.
And a fracked well lasts for 5 years, and they'll just refrack it.
Ask a question so that other people can.
Okay, so the question is, how do we stop it?
Well, I think y'all are doing, yeah, I've been keeping an eye on what you guys have been doing down there. But yeah, I think you're doing the right thing, which is constantly taking them to court.
Yeah.
You know, and you do have people that are collecting the nurdles and proving the pollution. And so that's what you have to do. It's the onus is on that was my point, right? I've said it a few times. The onus becomes on the citizens, and the citizens who are not reaping the benefits but are dealing with the detriments. And it's on you guys. And so taking them to court over every single thing you can, you've already won some settlements against them, right? So they've been in existence for less than a year. They've already been cited over a dozen times for air pollution violations, and they were fined like $12 million, $10 million? I know, it's a slap on the wrist to them. No, it is, exactly. And this is the problem, is that the fines don't kind of measure up to the profits that they're making, and so they'd rather just be fined and keep doing what they're doing. But they love to be, but you're doing the right thing, which is continuing to focus on them. Get them in the news, get it, you know, because I hear about it in Erie. So the more you guys do that's the right thing to do.
Thank you for your support.
Yeah.
One more question, and then Bob has.
But I'll be here all day.
Thank you for an outstanding presentation.
Oh, thank
I have
you.
a question about food packaged in plastic.
Yeah.
A lot of it, is, and when you buy that, to what extent are microparticles leached out into the food? And secondly, when the food is then heated in the microwave for 2-4 minutes, whatever, how much additional leaching of plastic is there from that point?
Yeah. If it's packaged in plastic, it has plastic. Some really interesting, disturbing, scientists say interesting when they, is a shelter word. Those takeout containers where you get like Chinese or whatever kind of food, and it's like black with the clear lid, and you pull it off, microplastics break off of that lid as you're pulling it off. They break off the walls of those containers when they put hot food into it. Just the act, we were the first to look at bottled water, but as studies have been done since then, but what we realized is just the act of opening the bottled water Just that act where you have plastic rubbing on plastic is releasing microplastics into the water that you're then going to drink. Yeah, so if it's packaged in plastic, it has plastic. I know if you touch, something that's plastic, it feels smooth and you think it's smooth, but your skin feels smooth too, and we know that it flakes off all the time, right? Like 20% of household dust is like skin cells or something obscene, right? This is true. So plastic objects feel smooth, but you look at them under a scanning electron microscope and you realize that they're not, and they flake continuously. So if it's packaged in plastic, it has plastic, and I know nobody wants to hear that, but that's true. And I know you don't have choices for some things, like I love cheese, and you can't find cheese that's not packaged in plastic, and so, I eat plastic, So that's the reality. Heating things up in plastic is a really bad idea. If you can avoid it, do. Again, though, I tend to worry more about our kids than ourselves, right? Like, I don't think anybody in this room is probably looking to have kids anytime soon, right? So I worry more about like my daughter who's of reproductive age. That's who I worry about, my students, because they're the ones who are really bearing the brunt of it. At this point, and my students ask me this all the time, these kind of questions. They're like, how do you deal? And I'm like, I'm gonna die, whatever, it doesn't matter to me, right? It's you that I'm worried about. So that's something to think about. But yeah, if you're heating something up for your grandkid, I definitely put it in glass. Yeah, ceramic, yeah. Thank you.
Thank you.